Okay, so we've talked about two of the three main paradigms of supervised learning, the classification and prediction. There's one more, which is sequence and prediction, and that's the only one of these where the notion of time and order matter. How we got to the data is as much as important as what the values are. So here's the simplest example I can think of. I might have multiple sequences, but in this case I just have one. So here's a list of lists, and each list contains a sequence, and our sequence here is some numbers: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So I think as humans we can pretty much predict what's going to happen next in this sequence. I'm going to train it on that, and it's going to use, in this case, a new method we haven't talked about finding hidden Markov chains. And so we've got this Markov method comes out, but we end up with a predictor just like other predictors. It's going to make a prediction, like classify, of what comes next. And I give it my sequence that it's going to predict on, and it hasn't seen a sequence strictly of 1, 2, but it's seen enough of that in this data to figure out that probably what comes next is a 3. And if I put in 1, 2, 3, it can predict that what comes out next is a 4. So that's just the simplest toy example. Let's look at an actual practical use of this, and one of those is things like automatic spelling correction or auto prompting that you see on your phone as you start typing text, trying to predict what word you might want to have next, or how a word might finish after you've partially typed it. And this is a sequence task. But doing it's pretty straightforward. It's exactly the same as we've done before. I'm going to take some example data. Let's have a quick look at that data. It's the text of Alice in Wonderland. And I'm going to take that book text and I'm going to turn it into a list of words, because we don't want to treat it as one string. We want to treat it as a sequence of one-word strings. And then we'll hit it with the sequence predict function. So it's going to go away and take all of those words and start trying to figure out what the patterns are of what word typically follows what. We can now take that function and apply it to some phrase. I'm going to start with the phrase, Alice was thinking. And rather than just make the next prediction, I actually want to see all of the probabilities of all of the different words that might come up. I'm going to sort those so that we get the most likely first. Well, actually they come last, so I have to reverse it. And then that will give me the most likely, and then I'll take the first 10 of those. So the code around it is just tearing apart the prediction that comes out. So here are the predictions of what word comes next, and hopefully those make sense. We've got Alice was thinking of. That seems like a perfectly reasonable prediction. Alice was thinking I. Yeah, maybe. Alice was thinking about. Definitely seems like a good one. And the numbers on the right-hand side here are the probabilities. So there's about a 6% chance that of was going to be the next word from the previous experience. Now, there is a sort of grey area of supervision, which is self-supervision. And that is if you can give the computer an oracle function, a function that can always tell the truth, then you can make it generate its own example data, and it can gain experience on its own without you having to feed it data collected from real-world experiments. Now, that might seem a little pointless. If you've got an oracle function, then surely you would use that rather than machine learning. But it is still useful if your oracle function is extremely expensive. So if you've got some grand simulation model that takes hours to run, but you need your answers in 5 seconds, then it's useful to run that very slow progress, taking hours over and over again over maybe the space of a few days or weeks, to generate enough data to make a fast model that isn't perhaps as accurate, but can make immediate response. I'll show you a simple example in action. Here's my oracle function. It's the most trivial I can think of. It's positive, asks the question, is something positive or negative? So it just returns true or false. And I ask it to do active classification. So it's like classify, but instead of giving it data, I give it the oracle function, and I tell it what space to explore. So I'm going to explore the interval from -10 to 10. And what it's going to do now is generate thousands and thousands of examples of numbers between -10 and 10, run the oracle function on them, and gain experience in how that function behaves. And now we've got a classifier function that is based not on the exact logic of positive, but on its experience of using the function. And hopefully that will now give the same results as the positive function, that if I give it a positive number, it gives me true, negative number, it gives me false. Another reason why you might use active classification is if you're actually running physical experiments. Active classification could control equipment to go and run an experiment and capture a piece of data, or to run some kind of web form and take data from users. So it's actually in the loop of gathering the data, rather than it being the process of gather first and then predict.